Okay, so here's another example that we want to find. Okay, that's 16 there. Sorry, just fixing it up. So this time we are evaluating a definite integral. Okay, so we want to find the integral from 0 to pi over 16, okay, for this function. Okay, 4 times cos squared 4x dx. Okay, so it's just getting that a little bit harder. Okay, we don't need to worry about this 4. Okay, it's just a constant value. We can just factor it out, or not factor it, just put it, okay, that's out of our integral. Okay, so we're not worrying about it yet. I just want to concentrate on this part, okay, of cos squared 4x. Now, you would have seen from the other video of what cos squared 2x looked like. Okay, so now I'm just going to go back to that. If you didn't watch the other video and you came straight to this one, we know that cos 2x is 2 cos squared x minus 1. Okay, so that means if I multiply my angle, this one, by 4, I have to multiply this angle by 4 as well. So that means cos 8x is 2 cos squared 4x minus 1. Okay, that's just in case you didn't watch the other video when we solved for cos squared 2x. Now, if we solve for cos squared 4x, okay, we get cos squared 4x, okay, that equals 1 plus cos 8x over 2. Okay, you move the 1 over, becomes plus, divided by 2. Okay, same thing, you can factor out the half. So you get half 1 plus cos 8x. Okay, so that's what you have to do first. Okay, you have to know this first before you can even attempt to answer this question. Okay, so what are we going to do now? So we're going to I'm going to rewrite my integral here, okay, by substituting this in and taking the 4 out of the integral. Okay, so my integral becomes, okay, I've taken the 4 out, from 0 to pi over 16. Okay, now we know cos squared 4x is a half 1 plus cos 8x. Okay, so that's what we're finding with our integral. We can take this half out again, so this becomes 4 times a half, so 2. From 0 to pi over 16, 1 plus cos 8x dx. Now we can solve for our integral. We get 2x plus 1 over 8 sine 8x. From 0 to pi over 16, okay, we're not taking a plus c because it's an indefinite integral. Okay, we are going to evaluate this. Okay, so just be careful with evaluation. Okay, the pi over 16 substitutes in first. Okay, and then you're substituting the 0. So if you need your calculator for this part, that's fine. At this level, you should be answering it in exact form. Okay, even if the question does not state exact form, you may still get full marks, okay, if you approximate, but the markers expect you to be able to answer this in exact form. Okay, so let's go and do that. So I'm just going to write 2. Let's substitute this in. So we're going to substitute pi over 16 first. That's being plussed by, okay, let's look at this. So sine, so 8, so that's sine pi over 2, okay, which is 1. Okay, so this is 1 over 8 times 1. So that's 1 over 8. Okay, minus, well, if I substitute 0, I get 0, and sine 0 is 0 again. So this side is just 0. Okay, just showing you that. So that's, I mean, okay, maybe we didn't need to use our calculator there, but I mean, if you need to, go ahead and use it. That's fine. There's no non-calculator section in our exams, but like I said, you should be able to answer it in exact form. Okay, well, what do we get from here? Okay, we simply get, so this part's 0, expanded 2 out, we get pi over 8, okay, plus 1 over 4. Okay, I don't have to write units squared or anything. It is technically finding the area under this curve from 0 to pi over 16, but it's not asking us to do that. It's just asking us to find the value. Okay, and this will be our final answer.